Alright, so in this second video, we're going to talk about solving linear quadratic systems. So we're going to go back to the quadratics for just a second, for about a day or two. We'll do it algebraically, and then we'll do it graphically a little bit later. So in a linear quadratic system, all that means is one equation has an x squared in it. It has a quadratic. When we're solving these, we have to use substitution. That's going to be our best option here. So with substitution, we want to get y by itself in the equation that that has the x squared. So we have x squared minus y equals 24. We want to make this say y equals so we want to move the x squared over, which leaves me with negative y, but I don't want to know what negative y is equal to. I want to know what y is equal to. So y is equal to x squared, minus 24. So now that we have the y variable by itself, we're going to use substitution. So I'm going to go into the second equation, which is 3x minus 3y equals 36. And in this second equation, I know that y is equal to x squared minus 24. So I'm going to substitute x squared minus 24 for y. Then I'm going to distribute this 3. So negative 3 times x squared is negative 3x squared. Negative 3 times negative 24 is positive 72. That equals 36. And then we need to remember how to solve a quadratic equation from our previous two exams. So solving a quadratic equation, we need everything on one side of the equation. I'm going to write x squared first, just because that's normal. We need to subtract the 36. So we're left with negative 3x squared plus 3x plus 36 equals 0. Now we need to solve the quadratic equation. We can factor, we can quadratic formula, you can complete the square, whatever. It doesn't matter which method you choose. Factoring is probably going to be the easiest, but if you don't want to factor and you want to use the quadratic formula, that's fine. The quadratic formula will always work, so we can always use it. But I'm going to factor. So if I look, all of these can be divided by 3. So all of these can be divided by 3. So I'm going to factor out a negative 3. So it's x squared minus x minus 12 equals 0. Then I need factors of negative 12 that add to negative 1. So this is going to factor to x minus 4, x plus 3. So when we're solving a linear quadratic system, we're going to end up with a quadratic equation, and then we're going to have to solve that like we've been solving, with either factoring or quadratic formula, or even completing the square if you wanted to go that route. So my answers here are x equals 4, and negative 3 would be my solutions, or my x-intercepts, but here it's going to be solutions. That's what we're going to call them. So if I have two different x values, I'm also going to have two y values for answers, because in a quadratic, more than likely, we're going to have two separate instances where the line intersects the parabola. So, I'm going to write my answers down here. So I'm going to have two answers, x equals 4 and some y value, and x equals negative 3 and some y value that goes with those x's. So I know that x squared minus y equals 24. So I'm going to have two different things. So when x equals 4, it's 4 squared minus y equals 24. So 16 minus y equals 24. So negative y equals 8. So y equals negative 8. So when x equals 4, y equals negative 8. When x equals negative 3, we have negative 3 squared minus y equals 24. And y equals negative 13. So my answers are the ordered pair for negative 8 and the ordered pair negative 3, negative 13. So in a linear quadratic system, we are getting y by itself in the equation that has the x squared, which is what I did in dark blue. So we get y by itself. Then in the crimson next to the blue, we are taking what y is equal to, so in this case x squared minus 24. We're taking what y is equal to and substituting that into the second equation for y, which will leave you with a quadratic equation. Then we have to remember how to factor or quadratic formula to solve the actual quadratic. And then after we solve that actual quadratic, we get x equals 4 and negative 3. So I have two different solutions. I have when x equals 4, which is in purple, and the y value that goes with positive 4 is negative 8. Then I also have an x value of negative 3, and when x equals negative 3, the y value that goes with that is negative 13. And the solutions are in the bottom left corner in purple and highlighted. So I have two different solutions. One solution is 4, negative 8. The other solution is negative 3, negative 13. And I have one more example, but I'll try to go a little faster. All right, so we need to get y by itself in the equation in the equation that has the quadratic. Well, lucky for us, that's already taken care of. If you look in the second equation, the equation that has the quadratic already has y by itself. So we're going to substitute for y. So in the first equation, I'm going to copy down the first equation, but instead of y, I wrote what y is equal to. And since it's a minus, we need to distribute this negative to all three things. Combine like terms. And then now we want to get everything on one side. And now we factor. So I'm going to factor in a different color. So we have negative x squared plus 5x minus 4 equals 0. So we have negative x squared plus 4x plus 1x minus 4. So my factors are x minus 4 negative x plus 1. So x equals 4 and 1. So again, I'm going to have two answers. I'm going to have when x equals 1, so we have when x equals 1, x minus y equals negative 2. If x is equal to 1, y equals 3. When x equals 4, you know x minus y equals negative 2. And y equals 6. So my answers here are 1, 3, and 4, 6. So final recap. Get the y variable by itself in the equation that has the quadratic. Then you're going to substitute the quadratic piece of the equation into the first equation for y. That's going to leave you with a quadratic equation which you can factor or use a quadratic formula. Either way is fine. And that's going to give us our two x values. After we find our two x values, we plug both x values into one of the equations, solve for the y that goes with that x value, and our answers here are going to be two separate ordered pairs.